myopia, 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 myopia. Near distance we can see her, far distance we can see her. Myopia, 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 myopia. Near distance we can see her, far distance we can see her. Myopia, myopia, myopia. For that correction we are using, bro. What, bro? For that correction we are using. For that correction we are using. Concave lens, concave lens, concave lens, concave lens. Hypermetropia, 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 hypermetropia. Far distance we can see, near distance we can see. Hypermetropia, 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 hypermetropia. For the correction, we are using convex lens, convex lens, convex lens, convex lens. Hypermetropia, 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 hypermetropia. Far distance we can see, near distance we can see. Hypermetropia, 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 hypermetropia. Convex lens, convex lens, convex lens, convex lens. Hypermetropia. New Cartesian sign convention, new Cartesian sign convention. All distance measured from the pole. Distance positive along the incident rays. Distance negative opposite to incident rays. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian sign convention, new Cartesian sign convention. New Cartesian sign convention, new Cartesian sign convention. All distance measured from the pole. Distance positive along the instant rays. Distance negative opposite to instant rays. Distance positive above the principal axis. Distance negative below the principal axis. Cartesian sign convention, 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 Cartesian sign convention. All distance measured separated from the distance are positive. Along the incident lines, distance are negative. Opposite to incident lines, distance are positive. Above the principal axis, distance are negative. Below the principal axis. Oh, hi everyone, welcome to the class. So now today we are going to discuss about electricity, electric current. So electric current chapter. Rate of law of charge, SI unit of electric current is ampere. I equal to Q by T. So electric current, CBSE grade 10 physics, electric current. Okay, so electric current, CBSE grade 10 physics. So when normally if you are taking, normally if you are considering I equal to Q by T, I equal to Q by T. SI unit of current is so ampere. SI unit of charge is coulomb. SI unit of current is ampere. SI unit of charge is coulomb. So now we are considering rate of flow of charge. So I am considering I equal to Q by T. I equal to Q by T. So SI unit of current is ampere. SI unit of current is ampere. SI unit of current is ampere. I am taking SI unit of current is ampere. So that is nothing but capital S symbol. SI unit of charge is coulomb. SI unit of charge is coulomb. That is nothing but C. SI unit of time is second. SI unit of time is second. Okay, yes. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called electric current. I equal to Q by T. Okay. So here I'm considering 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area. So I'm taking here. So if the current is passing through this one, okay. So here like this, through this one, it will pass. So 1 ampere is defined as electric current is defined as so 1 coulomb of charge, the rate of flow of charge, So normally electric current is defined as rate of flow of charge, charge flowing through unit cross section area per second. Charge is flowing through unit cross section area per second. Is called electric current. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So that is nothing but 1 ampere equal to 1 coulomb per 1 second. 1 coulomb per 1 second. So if the current is passing like this, this area of the cross section, okay, so 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called 1 ampere. Right? So now we can see now. So one more point we are discussing. So that is about current. So here electrons inside of the conductor, electrons will not flow only single or one like that. There are bunch of electrons will flow. So that is about quantization of charge. So that is nothing but Q equal to plus or minus Ne. So Q equal to plus or minus Ne. Q equal to plus or minus Ne. So number of electrons flowing inside of the conductor. Number of electrons are flowing inside of the conductor. So there is a quantization of charge. Quantization of charge. Quantization of charge. So so normally I equal to Q by T, right? So Q in the place of Q, we will take plus or minus Ne. Q are taking plus or minus Ne. Q equal to plus or minus Ne. Q equal to plus or minus Ne. So here if you are taking I equal to Q is nothing but Ne by T. Q equal to Ne by T. Q equal to Ne by T. So here is the number of electron I said. So equal to 1.6 into 10 power minus 19 coulomb. So on one electron, how much charge is present? On one electron, how much charge is present? On one electron, and one electron you can observe on one electron, so 1.6 into 10 power minus 19 coulomb. 1.6 into 10 power minus 19 coulomb. So in one electron, how many electrons in on one electron, how much charge is present? On one electron, how much charge is present? On one electron, how much charge is present? 1.6 into 10 power minus 19 coulomb. 1.6 into 10 power minus 19 coulomb. So in one electron, how many in one coulomb, in one coulomb, how many electrons are present? In one coulomb, how many electrons are present? We'll discuss now. We'll discuss. So here you can see. So I equal to Q by T I'm taking. I equal to Q by T, right? I equal to Q by T. Okay. So that's enough. I equal to Q by T. I equal to Q by T. Q equal to Ne I said plus or minus Ne. So I equal to plus or minus Ne by T. So that one, so on one electron, how much charge is present? On one electron 1.6 into, on one electron 1.6 into 10 power minus 19 coulomb. On one electron, on one electron, on one electron, yes, so on one electron, so if you are taking 1.6 into 10 power minus 19 coulomb, in 1 coulomb, how many electrons are present? Yes, Amulya, correct. So in 1 coulomb, so 1 by 1.6 into 10 power minus 19, 10 power 9 minus 19. So if it is goes up, so 1 by 1.6 into, so 10 by 10 you are taking, 10 by 10 you are taking, 10 power 19, 10 power 19. So if you multiply, you'll get 10 by, so 16 you'll get, that is 10 power 19. So if you do this, we'll get it. So if you do this, you'll get 0.625 into 10 power 19, 10 power 19. So in one coulomb, so 0.625 into 10 power minus 19 you'll get. So the same thing I'm taking, same thing. So if you are considering one coulomb, so 6.25 into 10 power 18 electron. So very, very important this point, very, very important. So the 3 marks question will come, either 1 mark question will come. So along these values they will ask. So I equal to Q by T, I equal to Q by T they will ask. I equal to I equal to Q by T, I equal to Q by T, Q equal to plus or minus Ne, I equal to plus or minus Ne by T. So in on one electron, how much charge is present? On one electron, how much charge is present? So 1.6 into 10 power minus 19, 1.6 into 10 power minus 19 coulomb. So if you are taking 1 coulomb, how many electrons are present? In 1 coulomb, how many electrons are present? So 1 coulomb equal to 1 by 1.6 into 10 power minus 19. So 1 by 1.6 into 10 by 10. So into 10 power 19. So if you are if you are solving this one, you'll get it. If you are solving this one, you'll get the value. So 6.25 into 10 power 18 electrons. 6.25 into 10 power 18 electrons, right? Yes. So related to this one, Related to this one, we'll do problems. Actually, we are considering now. Related to this one problem will do it. Okay. So related to I equal to Q by T, right? So this question we did in the previous classes. So anyway, still we have to work out on it. Okay, problems are very important, right? Done. As I said, calculate the number of electrons constituting 1 coulomb of charge. Calculate the number of electrons. Calculate the number of electrons constituting 1 coulomb of charge. So that only they given. So we have to find out a number of electrons. So previously whatever I explained, that only we can do it. That only we can do it. Okay. Next one. So still we'll do it the same problem. We'll do it the same problem. Okay. So here we are considering. Huh. A total number of, so a total number I'm considering a total number of, so 6 into 10 power 46 electrons flows through a current carrying conductor. When connected through an external power supply for 20 seconds, find the value of current in the conductor. Find the value of current in the conductor. So this question is very important. This question is very important. Make sure that you are practicing this one. I'll explain. Okay, I'll write on the board. I'll write on the board. Check once. I'll write on the board. Check once. A total of question number a total of 6 into 10 power 46 electrons electrons flow electrons flow through a current carrying carrying conductor when connected when connected when connected when connected through an external power external power supply for 20 seconds find the value of current in the conductor. So this is the question. A total of 6 into 10 power 46 electrons flows through a current carrying conductor when connected through an external power supply for 20 seconds. Find the value of current in the conductor. So you have to find out the current. How to find out the current? How to find out the current, you say? So we are using same formula. Yes, I equal to Q by T. We are using. Okay, so we'll see. So yeah, now you can observe. First you have to identify the data, what is exactly given in the question. So first you have to identify the data. A total current. So this is the number of electrons flow through the current carrying conductor connected through an external power supply 20 seconds. So given data, first given data I have to take. Given data, given data, that is n equal to 6 into 10 power 46, and time equal to given, time equal to 20 seconds. So we can use the formula, we can use the formula, we can use the formula, we can use the formula. Okay, so that is I equal to q by t, that is nothing but ne by t. So, but actually here one thing you need to understand, as I said in the previous explanation, compulsory one value you have to remember without any doubts, without any doubts. That question definitely they will ask, that this type of question definitely they will ask. So compulsory you must remember, you must remember, because that is very very important. Okay, so without knowing that one we can't do the problem, we can't do the problem. Okay, so again it is a we will so in the exam time we will work out, in the exam time we'll struggle. Okay, so we'll get confusion like that, because the only, so here we are taking only, here we are taking, you can observe here, we can observe here one thing, you can observe here one thing. So the thing is, so that thing is, okay, we'll consider we don't know electron value, so this value we don't know, this value we don't know, we know only n value we know, n value we know, t value we know, we don't know e value, right? So we don't know the v value, right? So here they're asking, see, we can't use this formula, but they didn't give charge, they didn't give charge, time they given, okay fine, but they didn't give charge, right? How can we find out, how can we find out I value? They're asking to find out the current in the conductor, they're asking to find out current in the conductor. Without knowing the charge, we can't find out. But one more formula we can use. One more formula we can use. That is Ne we can use. Here n value they given, but n value given, t value given. Whatever e value we have to remember. That is e value is E value if you are taking, as I said in the previous class, so this value you have to remember 1.6 into 10 power minus 19 coulomb. Compulsory you have to remember that value. Now you substitute here I equal to, so n is how much, 6 into 10 power 46 into E value 1.6 into 10 power minus 19 by, so T value how much, 20 seconds, 20 seconds. So T value is 20 seconds. So let me know what is the answer. How much you will get the answer? Can anybody solve and tell me the answer? Okay. So I got the answer 4.8 into. So answer is whatever I got the answer. Answer is 4.8 into 4.8 into 10 power 10 power 26 ampere. So I got this answer. So remember, try to solve. Calculation you have to do it at any cost. So here you can multiply. See, this one we can cancel it. Like how much it will be? Minus 46 minus 19. You can do it. And so 1.6 into 6 you can multiply by 20. So if you do, you'll get the value. You'll get the value. Check once. So check once. I hope it is clear to you all. So clear to you all. Okay, so next one we'll do one more problem related to uh, I equal to q by t, related to current related to current. We'll do one more problem. Shall we do it? Shall we try? Shall we do the problem? Okay, so we'll do it now. Yeah, one more problem. A current of 150 milliampere. Actually, why I'm telling this one means these are very very important. So many times. So related to these conversions, I will ask. So I'm talking about only these two means. So related to conversions, very very important. So that's why I'm explaining these two. Remaining problems also there. Remaining problems also there. So 1 milliampere equal microampere. Conversion is very important. Conversion is very important. Okay. So now I'm considering like this. Okay, so now a current of. So we'll discuss this one. A current of, a current of, a current question. A current of, a current of 150 milliampere flows through, flows through. A current of 150 milliampere flows through. Okay, flows through a circuit. Flows through a circuit. Flows through a circuit. Flows through a circuit for 2 minutes. Find the amount of find the find the amount of charge that that flows through the circuit. Flows through the circuit. Okay. So here they're asking, now you can see here a current of 150 milliampere flows through a current of 150 milliampere flows through a circuit for 2 minutes. Find the amount of charge that flows through the circuit. Can anybody solve this one? How much you'll get? How to solve? Can you try it once? So try this question. What is the answer? So here you see milliampere they given. So as I said, when I given the problem, you must so here you can see. So a current of 150 milliampere flows through a circuit 2 minutes. 2 minutes. Find the amount of charge that flows through the circuit. So find the amount of charge they are asking to find out. So Q you have to find out. Q you have to find out. Okay. So here current is given. Current is given. Current is given, right? Current is given. Current is given. Okay. So now you can see I equal to I equal to 150 milliampere. 150 milli. I equal to 150 milliampere. Time equal to time given 2 minutes. Time given 2 minutes. Right? Time given 2 minutes. And find out the amount of charge they asked. Find the amount of charge. Yes or no? Find the amount of charge they asked. So they're asking to find out the amount of charge. Amount of charge they're asking. Amount of the charge. So now we can see. Now we can see. We know the formula I equal to Q by T. I equal to Q by T that flows through the circuit. So 2 minutes they given, right? 2 minutes. So 2 minutes means, so how much? 2 minutes means how much we can take? 1 minute equal to how many seconds? 60 seconds. Okay, na? So now you can observe. So 2 minutes mean 2 into 60. That is nothing but 120 seconds. 120 seconds. Current is given, but here current is milliampere. 1 milliampere equal to 10 power minus 3 ampere. So I equal to 150 into 10 power minus 3 ampere. Then I equal to, so I we know, right? I we know. So I we know, right? 150 150 into 10 power minus 3 equal to q we need to find out. Charge only, right? Q by 120 seconds. 120 seconds. Q equal to 150 into 10 power minus 3 into 120. How much you'll get? I hope answer is 18C. 18 coulomb. So Q equal to 18C. Is it clear? So that is a question and answer too. So a current of, so here a current of 150 milliampere flows through a circuit for 2 minutes. Find the amount of charge that flows through the circuit. Find the amount of charge that flows through the circuit. Okay. Now you can see. Is it clear or not? Is it visible to everyone? Okay. So sorry for that. So small interruption. So due to, okay. Thank you so much. Okay, fine. So now let's get into the topic. let's get into the topic. I hope it is very clear to you all. Audible also. Yes or no? Is it audible? Is it audible? If it is audible, let me know. Okay, done. So that we will get, that is 18C. So that is the answer. That is the answer, right? So now we will go to we are going to the next one. We are going to the next one. So till now we discussed about till now. So till now potential difference. Now we'll discuss about potential difference. Already electric current is completed. I equal to Q by T. I equal to Q by T is completed. Now we are going to discuss about potential difference. Okay, so potential difference is nothing but work done to bring unit positive charge from one point to another point. Work done to bring. So I am taking potential difference. So before that, only electric current we discussed, right? We will discuss about electrical appliances. Electrical appliance will discuss. Okay, electrical appliances. Those are, first one is cell, positive terminal, negative terminal. Second one is battery. Battery I am taking. So positive terminal, negative terminal, battery. And third one switch. Switch I am taking. This is a switch. Actually it is closed switch. If you are not placing the dot, so that is open switch. This is open switch. Okay, open switch. And next one is a closed switch. So if dot is there, that is called closed switch. If dot is not there, that is open switch. And fourth one, closed switch. Open switch and closed switch. Okay, now we'll discuss about resistor. Fifth one is resistor. And sixth one is rheostat. Or rheostat is nothing but the device which is used to regulate the current. Regulate the current. Rheostat is nothing but, so it is a device. Rheostat is the electrical appliances which regulate the current without changing the voltage source. So rheostat is a device which regulate the current without changing the voltage source. So now we are taking rheostat. Resistor is a device. So which is oppose the electric current in the circuit. A resistor is a device which is used to oppose which is used to oppose the electric current in the circuit, which is used to oppose the electric current in the circuit. So which is used to oppose the electric current in the circuit. Electric current in the circuit. So which is used to oppose the electric current in the circuit. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Resistor is a device which is used to oppose the electric current. Resistance is the resistance. Resistance is the phenomena of opposing the electric current in the circuit. Resistance is the phenomena of opposing the electric current in the circuit. Okay. So cell, battery, open switch, closed switch, resistor, and rheostat. Next one we are going to the seventh one, ammeter. Ammeter I'm taking ammeter. So this is the ammeter, positive terminal, negative terminal. Coming to the voltmeter. This is voltmeter, positive terminal, negative terminal. Next one is so bulb I am taking. 10th one is wire joining. This is wire joining, and 11th one wire crossing. So this is wire crossing. So these are the electrical appliances: cell, battery, open switch, closed switch, resistor. Resistor is a device. Resistor is a device which is used to resistor. Resistor is a device. Resistor is a device which is used to oppose the electric current in the circuit. Resistance is the phenomena of opposing the electric current. SI unit of resistance is ohm. SI unit of resistance is ohm. And rheostat. Rheostat is a device which is used to regulate the current, without changing the voltage source. So which is used to regulate the current without changing the voltage source. That is called rheostat. Ammeter, voltmeter, bulb. This is one. What is this one? Wire joining, wire crossing. Cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, bulb, wire joining, wire crossing. Cell, battery, open switch, closed switch, resistor, and resistance is the phenomena. Rheostat, ammeter, voltmeter, bulb, wire joining, wire crossing. So okay, so this is about electrical appliances. Coming to the next one now. Electric circuit. Electric current is completed. We'll discuss about electric circuit. Electric circuit. Electric circuit is nothing but electric circuit is nothing but electric circuit is nothing but electric circuit. You am taking electric circuit. Electric circuit. Electric circuit. Electric circuit is nothing but a continuous and closed path of an electric current. An electric circuit. An electric circuit is nothing but a continuous and closed path of an electric current. A continuous and closed path of an electric current is nothing but a continuous and closed path of an electric current. A continuous and closed path of an electric current. A continuous and closed path of an electric current is nothing but electric circuit. So here we can see I am taking the electric circuit. Already explained about positive negatives. I am taking this a battery. So here positive terminal, negative terminal, battery I'm considering. So this is a bulb. So current is passing. So current is passing. Current is passing from positive terminal to negative terminal. Current is passing from positive terminal to negative terminal. Okay. So current is passing. If the current is passing, a closed and continuous path of an electric current. A closed and continuous path of an electric current is known as an electric circuit. A closed and continuous path of an electric current is known as an electric circuit. A closed and continuous path of an electric current is known as an electric circuit. A closed and continuous path of an electric current is known as an electric circuit. A closed and continuous path of an electric current is known as an electric circuit. A closed and continuous path of an electric current is known as electric circuit. A closed and continuous path of an electric current is known as an electric circuit. A closed and continuous path of an electric current is known as an electric circuit. So if the current is passing here, so here the current is passing from positive terminal to negative terminal. So before finding electron, proton, so scientists were given definition, the flow of positive charges, the flow of positive charges is considered as the flow of electric current, But actually after finding no electron, proton, so scientists were identified that so the flow of electrons, the movement of the electrons, gives the flow of current in the circuit. So that's why I'm taking here. So the flow of positive charges is considered as a conventional current. Flow of positive charges is considered as a conventional current. Flow of electrons is considered as the electric current. Flow of conventional current. Conventional current. And second one is conventional current, and second one is electric current. Conventional current is nothing but the flow of positive charges. The flow of positive charges is considered as a conventional current. So the direction of flow of positive charge is called direction of flow of current. So here you can consider electric current. Electric current is nothing but the flow of electrons. The flow of electrons is called electric current. The flow of electrons is called electric current. Okay. So conventional current and electric current. Conventional current is nothing but flow of positive charges. Electric current is nothing but flow of negative charges. So conventional current and electric current we know. Next one we are going to discuss about potential difference and electrical potential. That we will discuss. We will see. Okay. So now we will take breaks half an hour. So again from one we will start. Okay. So from one onwards we'll start once again. One onwards we'll start once again all the points like electric circuit, electric current, potential difference, electrical potential related to that formula, Ohm's law, resistors are connected in series combination, resistors are connected in parallel combination. This all we'll discuss. Resistors are connected in series combination, resistors are connected in parallel combination, and the heating effect of electric current. So till now we discussed about current, the rate of flow of charge. SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. So 1 ampere is defined as 1 coulomb of charge charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb per 1 second. So that is about 1 ampere. And coming to the next one, electric circuit, a continuous and closed path of an electric current is known as an electric circuit. Electric appliance, cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, and bulb, wire joining, wire crossing. These are the electrical appliances. After completion of that, we are going to the conventional current and the electric current. The flow of positive charges, the flow of positive charges, the flow of positive charges is considered as a conventional current. So the flow of electrons, the flow of electrons, conventional current, the conventional current, conventional current, conventional current. So the flow of positive charges from positive terminal to negative terminal is considered flow of positive charges. Negative terminal to positive terminal will be considered as a electric current. So this is about okay. So that is about electric current. I hope it is very clear. So we'll go to the next one. Next one we'll see. 1 o'clock. 1 o'clock. Okay, 1 o'clock we'll discuss again same topics. We'll see. So we'll see. We'll see. Thank you so much. We'll see 1 o'clock join to the class. 1 o'clock join to the class. We'll discuss remaining points. Thank you so much for joining and attending. So this is your Seva sir signing off. Namaste.